All right, this is section 13, topic 4. And it is called Radian Measure Part 2. Target. How do you use reference angles to evaluate trigonometric functions? All right, so it's pretty much a review, like I said, of what we've already done. Okay, we did more advanced problems a few sections back, so you pretty much already know this. It's basically more practice on the homework we just went over with finding sine and cosine. Okay, a reference angle, and we've even talked about reference angles before, we just haven't written down the definition, is an acute angle formed by the terminal side of a given angle and the x-axis. Reference triangles can be used to evaluate the trigonometric values of an angle whose terminal side is not in quadrant 1. So like if we draw a 130-degree angle, how we don't use that angle actually to find the sine and cosine, we use the other angle that it forms would be, that angle would be the reference angle, and the triangle that we use is the reference triangle. Okay, so for example, like I just said, I'm just going to draw that real quick. So I'm going to draw a unit circle. And I'm going to draw in a 120-degree angle. So we know 0 degrees, 90 degrees, 180 degrees, 270 degrees. What quadrant would 120 degrees be in? 2. So if we go up here as 90, we need to go 30 more degrees, right? That would make this whole thing, this terminal side, would form a positive 120-degree angle. So we know from here to here was 90 degrees, then we had to go another 30 degrees. But that 30-degree angle, we're not able to use that to find sine and cosine, are we? We can't draw the terminal side. We don't draw a perpendicular line to the y-axis ever. So we have to use the other side of it, which we've learned that before. And so that other side, the 60-degree angle, that would be called our reference angle. So it's not part of the angle that we drew in, it's the other side of it. We're going to use it as a point of reference, and we're going to make a triangle using that reference angle, and that would be referred to as the reference triangle. Okay, feel cool with that? Okay, next page. 2 unit circles, finished. Example 1. I'm going to draw again another big old unit circle. And I'm going to write some questions out to the side. Part A, we're going to evaluate the sine of 2 pi over 3. Part B, we will evaluate the cosine of 2 pi over 3. And part C, we are going to find the cosine, or find the coordinates of where the terminal side intersects the unit circle. Okay, so sine and cosine. Do you remember when you're finding sine, what are you actually finding?
The y.
The y value, right? And when you're finding the cosine, what are you actually finding? X value, right? So I just like to write that. Cosine of theta is your x value when you're talking about a unit circle. And the sine of theta is your y value when you're talking about the unit circle. And that's always because the hypotenuse is 1. All right, well, we have to figure out where are we going to draw this terminal side. Like, where is 2 pi over 3? So what I would do is, me personally, you could look back at your unit circle, or you could just convert, that's in radians right now, right? We could also easily just convert 2 pi over 3 to degrees. Do y'all remember how to convert radians to degrees?
You plug in 180 in the pi.
Exactly. So it'll be, instead of 2 pi, it'll be 2 times 180, quantity divided by 3. So that is 360 degrees divided by 3, which is 120 degrees, which we just drew a 120 degree angle on the last page, right? So it's positive, so we go counterclockwise. So I wrote 90 degrees. 0 degrees up to 90 degrees, down to 180 degrees, down to 270 degrees. We already know that 120 degrees is in the second quadrant. We just drew it. Bless you. So we want the sine and the cosine of that 120 degree angle. But can you have 120 degrees in a right triangle? Doesn't work, right? And at right triangle, 90 degrees is the largest angle you have. So while we want to know this ordered pair, well, this angle, I mean, there's two sides of it, so we use the other side, this reference angle, to help us answer the question. So how many degrees is in this reference angle?
30,
Well, there's 30 degrees right here,
60.
but the reference angle would be this one, 60, right? And then we're gonna draw the right triangle. And let's label our sides. What's the length of the hypotenuse again?
1.
1, always in a unit circle, it's 1. In a unit circle, what's the length of the smallest side, which is always across from the smallest angle?
1/2.
1/2, good. And then what's the length of the side across from the 60-degree angle? No.
It's radical 3/2.
Square root of 3/2. All right, think about it. Your x values in this quadrant, are they positive or negative? You're negative. And your y values in this quadrant are positive. So when we're finding the sine of 2 pi over 3, we're finding the y values, right? Those are positive. What is the sine of 2 pi over 3?
1.
Note 1's all your hypotenuse. It's not going to be your sine or your cosine.
Radical 3/2. I know.
Right, it's square root of 3/2. It's always the height of the triangle. So your y values are positive in that quadrant. So what's the cosine? We're same angle, 2 pi over 3. What's the cosine?
1/2.
And what's the sine of it? SIGN of it?
Negative.
-1/2, right? Because it's your x value. It's the distance from here to here on the unit circle. That distance, that's the length of 1/2, right? We know if we went all the way to the end of the circle, that's 0. Or 0. That's 1. Because every radius on the unit circle is 1. So find the coordinates of where the terminal side intersects the unit circle. Well, we already found the x and the y value, right? So now we just have to write it in order. Our x value is -1/2. Our y value is positive square root of 3/2. Coolio? And if you haven't been here, I would say definitely need to go watch the videos from the classes that you missed. Just taking the notes, if I were you, that wouldn't work for me. I probably wouldn't be able to understand what is going on. I would definitely want to watch the videos to help me. So we're going to do one more example just like that. Draw a unit circle. And this time we're going to evaluate sine and cosine of 7 pi over 6. All right, so first thing I want to do is, okay, I got to figure out where is 7 pi over 6. That's in radians. We could look back at the unit circle, kind of figure out where 7 pi over 6 is, or we could just convert it to degrees, which is what I prefer to do. So let me see. That would be 7 times 180 degrees, quantity divided by 6, which is 7 times 180 degrees is 1,260 degrees. Divide that by 6 and we get 210 degrees. What quadrant's 210 degrees going to be in? The third quadrant, right? So we'll go 0 to 90 to 180. It's over 180 degrees, but it's not over 270 degrees. So once we get to 180 degrees, we have to go another 30 degrees, right? So I'm guesstimating about right there. So 90 plus 90 plus 30 should be 210 degrees. So this 30-degree angle, that's our reference angle, which is going to help us form the triangle, our reference triangle. So obviously this would be a 60-degree angle. Right? So we know our hypotenuse has a length of 1. The shortest side is across from the smallest angle, which is 30 degrees. What's the length of that leg? Anyone?
Sorry, what'd you ask?
What is the length of the leg across from the smallest angle?
3, radical 3.
That's the other one.
Oh,
1/2.
sorry, I got lost.
1/2. And then the angle, the side across from the 60-degree angle, that's the one that's the square root of 3 over 2.
I was trying to make my triangle and I didn't know what you were asking.
Oh, that's okay. So in quadrant 3, are our x values positive or negative in this quadrant?
Negative.
Negative. And what about our y values?
Negative.
Negative. So we know our ordered pair, the cosine and the sine is going to be negative, right? Okay. So what is the sine of 7 pi over 6?
Negative 1/2.
Negative 1/2. That's your y value. So what's the cosine of 7 pi over 6?
Negative square root over 2.
Negative square root of 3 over 2. Good. And then obviously the ordered pair is your x value, comma, your y value, right? Your cosine, comma, your sine. So that would be negative square root of 3 over 2, comma, negative 1/2. And that's it. That's the whole lesson. Boom, just like that. Our assignment, we have 15 minutes and you'll probably be finished before. You're still not allowed to complain. I'm still recording. Okay. Everybody cool? All right, and if you need to see this after I stop the video, no problem.